Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called Even Arrows by Michael Lefkowitz. And here are the rules. We have normal Sudoku rules applied, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. And we have even arrows, where a digit on the arrow indicates how many cells in the indicated direction, including itself, contain an even digit. So this would basically count the digits here, which are even, including itself. So if we had, say, 4 here, this would count itself, and this would have to say that the 4 out of these 8 cells here that it sees on its path are even. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so for each row and column, the most digits you can have on that are even in a row or column. Well, first of all, this counts the same number as okay, let's do those. Where are digits that are counting the same direction that are in the same row or column? And these two are. So this is going to see as many cells as this cell does that are even, plus at least one more. And since this is the only digit left that this one doesn't count, this must be even. Same with this. These are pointing in the same direction. This counts a certain number. This must count at least one more because it counts the same number here, and then at least one more, and therefore this must be even. In a row and column, you can have at most 4 even digits, right? 2, 4, 6, and 8 can only appear once each. So anything that looks horizontally or vertically must be up to 4. This is up to 4. These are up to 4. This is up to 4. These see at most 3 cells. So this is up to 4 because it sees 4. This is up to 4. This is up to 4. We have up to 4 here. This sees 2 cells at most. So this is 1 or 2. This sees 3 cells. So that's 1, 2, or 3. Same with that. That's 1, 2, or 3. Okay. So these cells both see the same amount of cells here. So this sees these cells in row 5. This sees these cells in row 5. One of them is going to have to be a 4. Right? Maybe not. So this counts those number of cells that are even. If neither of these are 4, that means we have a guaranteed even here and a guaranteed even here. But then these would have to be the same digit because this counts these cells here plus that one, which would be even. And this counts these cells here plus this one, which would also be an even cell. So these would be the same amount of even cells, and then these both... So these have to be opposite parities, then. And one of them is going to be smaller than the other, which means... And it has to be one smaller by 1. So one of them is going to have to see all 4 evens, The other one must see 3 of them, and we have an odd even pair in row 5 at the ends. We don't know which one's which. So this has to be 3 or 4. This is 3 or 4. That eliminates 3 or 4 in the rest of the row. So this is guaranteed to be 1 or 2. We have a 1, 2, 3, 4 quadruplet in row 6, which eliminates 1, 2, 3, 4 in the rest of the row. So these must be 5 through 9 here remaining. So we have a guaranteed 4 in one of these 4 cells. Okay. So this could be max 9. This is max 8. We're seeing 8 cells. Same with this. This is max 8, I think, also. Max 1, 2, 3, 4, 5, 6. Max 8, max 9. Max 7. This is also, I think, max... Oh, this is max 8 also. 1, 2, 3, 4, 5, 6, 7, 8. So neither of these can be 9. Because again, they have to be even digits. So this is at most 8, which means this has to be at most 7 here. This way. These could be the same digit, so we don't have the same limitations as we do in row 5, or digits being the same row or column. Oh, this is going to have to be the opposite of this digit here. So this is going to have to be an odd digit here, right? Because this is going to see as many even digits as this one does, plus 1. And we know it has to be an even digit itself. So then this must be 1, 3, 5. So this is also the same. This is odd, and this is 1, 3, 5, 7, and we have this being 2, 4, 6, 8. Okay. The remaining digits of row 5 have to be 1, 2, 5 through 9. Okay. If this is 1, that means there's only 1 even here. If this is 2, this is even, it counts itself, and there would only be 1 more even here. So either way, there's one even and three odds here. In row 6. So one of these two at least is even. It could be both of them. In row 6, the set of even digits here must be different than the set of even digits here. Because if they're the same, then these would have to count the same amount of even cells, right? These is the same as that. Obviously, these share both seeing all of these three cells. So then it would see all of these. These would then share the same digit, which is not possible. What happens if one of these is 7 and 8? That means all of these digits would be even. Okay. So this would be even. It would have to be 2. That means this could not be, this would have to be even. It would have to be 4. So these would have to all be odd in that case. No 2 or 4. We'd have to have 4 evens here. So 6 and 8 could not be here. 8 would be here, so this couldn't be 8. No 2. So these would all be even. This would see how many? 1, 2, 3, 4, 5, 6, 7. So that's not allowed. So we know this cannot be 7. This can't be 8. This cannot be 8. Can it be 7? If it's 7, we have 1, 2, 3, 4, 5, 6. No. So this is 6 at most here. Now, as an even digit. What about if we have 7 here? If this is 7 and 8, these would all be even. So that seems more likely. Again, we'd have 2 here. This would be 4, so these would be 3 odd digits. This would be odd, so no 2 or 4. That's 1 and 3. This would be 1 or 3. That would force this to be 2. So then none of these could be even, because we would see even here, even here. So this would not be even. These would all have to be odd. Okay, no 2 here. This would be odd. This would have to be 2 or 4. We'd have 6 or 8 here. This would have to see one odd digit. Or sorry, one even digit. Because we have three, you already have three odd digits here. Because you must see all four even digits this way. And therefore this can't be 3 ever. So this has to be 1. That would force this to be 3. So this sees 3 even digits this way. That does kind of work. This is the only digit that's not even. So then these would be odd. This again would have to be odd. We'd have to have even here. It would be a 6-8 pair. That eliminates 6-8 in the rest of the row. That eliminates 2, 6, and 8 here. This could still be 2. We don't know. 3 eliminates 3 here, so this would be 4. Which would force this to be 3. This is obviously odd. And we have a problem. We have a contradiction. So this would have to see all 4 evens. But the difference would have to be this would be even. But it can't be even because this sees only 2 evens. So this can't be 8 either. Interesting. That's kind of convoluted, but I mean, what else are you going to do, right? So this can't be 7 and 8. Not too helpful. So the issue was that the forced even here, which means we had 2, 4. So then this couldn't be 2 or 4, which means this had to be 2. So that was problematic. So this can never see 1, or it could see 1. If all of these were odd, and then this was even, this would see 1 being there. That's it. Of these, you can't have 3. If this was 3, it counts itself, but then that would be odd, and then you can't have, you would only have 2 evens at most here. So this has to be 1 or 2 here. So this is a 1-2 pair, which eliminates 1 and 2 in the rest of the row. So that means the remaining digits in the rest of the row are 3 through 9. So one of them, so if it's 2, it sees itself, and then one of the other digits is even, which would be 4. So if this is 2, only one out of these 2 is even. If this is 1, only one out of these 2 is even. Interesting. Huh. So this becomes a blue-red pair also here. Because only one out of these digits is even, right? If this is 1, obviously only one of those is even. If this is 2, the 2 is already even, so then only one out of these 2 is even. Interesting. Um, what happens if these are 4? So if this is 4, that's 3, which makes that 4. Obviously, this has to be even. This is not even, that's odd. This is even. So then this can't be even, it's odd. This sees all 4 evens, therefore this is the even and this is the odd. That seems fine. No 4 here, no 3 there. That seems fine. Hmm. That means no 4 here. 3 has to be one of these two. Because this becomes a 1, 2, 3 triplet in box 5, and 3 would then have to be there, so this would be 1. No 1 here, it's a 2, 3 pair, which eliminates 2 and 3 in the rest of the row. So this can't be 2, it's 1. Um, so this is 1 even remaining. So that would force this to be 2. That would force this to be 1. This would be even, this would be odd. 1 here means there's only 1 even in the rest of the column, which would be that one. So therefore, this would be all odd. That would eliminate odds in the rest of the column. So these are all even. This is odd. Three eliminates 3 here. No 1 here, no 2 here, no 4 here, no 3 here, no 1 or 2 here, no 1 here. 2 has to be one of these. This is 2, 6, or 8. Um, these can't be even. Must be all odd. Hmm. So no 8 here. It would have to be 3, 5, or 7. 1, 2, 3, 4, 5, 6, 7. still possible. Um, that is kind of interesting. What happens if we go the other way? It should be the same thing. It's just the opposite side. Oh, does that mean this is always 1? Probably, right? Hmm, that's not necessarily the case. So say we have 4 in one of these two spots. So the 4 is not necessarily going to be one of these two cells here, right? You could have 2. What happens if we have 2 here? That's 1. That would be odd. That makes that even, so it's 2. This cannot be even anymore. We see 1 even this way. This would be 3. That would be 4. No 2 or 4 there. It's odd. It's 1 or 3. No 2 this way. This can't see 4. We have an even that way. So 4 would have to be there. So this would be odd. This would be even. These would have to be both odd. This sees 4 evens that way, and that's a contradiction. Okay. So, I think we've proven 2 cannot be the even cell in one of these two cells here. So again, we have an odd and even pair in each of these, right? The only way that we cannot have a 4 is if this is 2. And we just showed that that leads to a contradiction, right? 2 is even, which means this is 1, which means this sees 1 even cell here, so this must be odd, which means 3, which means this is 4, which means this has to be even, but this 2 is pointing at 3 even cells at least in the column. And it's going to be the same way if this is 2. If this is 2, this becomes odd, it's 3, that makes 4 there. That means this must be even, and the 2 is pointing at least 3 evens in the column. So we're guaranteed a 4 has to be here or here, and this cannot be 2. So no 2 here. Where is the 2 in row 6? It must be one of these two cells, which eliminates 2 in the rest of the row, or in the rest of the box. So this can't be 2, it's 1. That eliminates 1 and 2 here. No 1 remaining in row 5. So this can't be 1 either. So we have a guaranteed 1 there. That's odd. 4 has to be one of these two. 4 has to be one of these two, which eliminates 4 in the rest of those rows. That means this can't be 4 and this can't be 4. So it's a 2-3 pair, which eliminates 2 and 3 in the rest of the row. So then this becomes a 1-4 pair here. So we know in box 6, 1 has to be one of those. In box 4, 1 has to be one of those. And if you have 4 here, that means this is going to be even. And then 4 evens, which means the remaining digits in the column are all odd, since all the evens are accounted for in these cells here. If this is 1 even, it has to be that one, which means the remaining digits are all odd, which means this has to be 3 evens here. So this is going to be either 3 evens or 3 odds in these cells here. That's interesting. If this is 3 odds, this has to be even. And that's going to be a contradiction. Okay. If we have 3 odds here, that means this has to be even to have at least one even here, but then you'd only be counting one even here total, and that would be an odd digit. So this cannot be three odds here. Therefore, this must be three evens here, which eliminates evens in the rest of the column. So then these are odd. This must be a 1 here, because this points to only one even. That means this is 4, so that must be even there. 4 eliminates 4 here, so it's 3, and that makes that 4. This is odd. This cannot be 1 because of 1 in the box, so that's 2, which makes this 1. So we have odd, odd. This sees only 3 even cells, so this must be even there. So it has to be that way. This is even here. That's 2. That eliminates 2 in the rest of the box. Whereas 2 in row 5, it must be one of those 2. These must be all odd. So this could still be 1, or it could be 2. These are all odd. This cannot be 8. Can't be 1. It's 3, 5, or 7 with a number of evens on this diagonal. This can't be 8. It's 1, 3, 5, 7 here. This can't be 1 here. This we don't really know. This is 2, 3 as a pair. If this is 2, it counts itself and one digit here as even. That would be 3. So that's very possible. And then we have another even there. Or if this is 3, that means this would be 2. And the 2 would count the 4 in itself. So then you'd have 2 evens there. So that's possible. Four eliminates 4 here. This can't be 3. So this is either seeing 2 here and 1, or 6 evens and 5. Okay. One out of these obvious. Okay, so 2 and 3 eliminate 2 and 3 in the rest of the box. No 3, 4 remaining here. So 3 has to be one of these 2 digits here. There's no 4 remaining because of 4 in the box. Three, 5, or 7. No more 3 here because of 3 in the column. This is odd. It sees 1 even there. Therefore, we have 3 out of the remaining 4 of these cells are even. That's interesting. No 6 or 8 here because they're both odds. We are guaranteed an 8 in one of these 3 cells. Huh. Hmm. Um. hmm. Let's say this is 6 and 5. Yep, 6 and 5 here. We have 1, 2, 3 odds already, so the rest must be even. That means this is 1, 2, 3, 4, 5, 6 also. That does satisfy the even. This is 2. That would be 3 there. This is odd. This would then have to be 2 and 1. So this is 2 evens. That's 1 even here, 1 even here. The rest cannot be even, so those are all odd. Therefore, this is 3. We have to have 1 even here. This is odd. This is even. Even here. No 6. So this would not be 5. 3 or 7. This sees 3 even cells, so we have 1 even cell here. Which means this sees 2, so this can't be even here. This must be odd. So this cannot see 7 odd even digits here. It can only, so it would be 3. Therefore, that would force this to be 3. There's no 3 here. This would have to be 7 or 9. That seems fine. 4, 6, or 8. It's 5, 7, 9. 6 or 8. It's 5, 7, 9. We have 1 even here, 1 even here. Neither of these can be 6. We have 1 even there. We don't know which. This cannot see 6 evens. It can be 4 at most. So this is 2 or 4, which means it isn't even. Because it can't be 1, 3 because of 1 in the row, 3 in the column. So far that's looking okay. I was hoping I would reach a contradiction, which is why. Oh, this is definitely 5. That eliminates 5 in the rest of the box. Dang, I was hoping that would lead to a contradiction, so that's why I was going down this path. This is looking like it's a nothing burger there. What else can we do? Can we maybe rule out 7? Is what I'm thinking. Here. If that's 7, that means all of these would have to be even. It's a lot of even cells. This would have to be a 6-8 pair. This could no longer see just 2 cells because itself, this and that digit would be, so And this would have to be 3. That would be 2. The problem is the 3 would see all 3 evens, so therefore there would be an even here, and then this would have to see 3 evens. So that's not going to work. Right, so this cannot be even, because then that fails this 3-2 pair, right? If this is even, this can't see 3 evens, because then this would see more than 2 evens that way. So this has to be odd guaranteed, which means this cannot be 7. We have a 1-3-5 triplet now in row 2, which eliminates 1-3-5 in the rest of the row. So we are guaranteed a 3 here. The remaining digits in the row are 2, 4, 6, 7, 8, 9. No 4 here because of 4 in the column. And this is at most 2, 4, or 6, pointing at 6 even digits. Can't be 6 because this is odd. So this must be 2 or 4 here, which makes that an even cell. Interesting. One of these is pointing at 3. If this is 3, it must be 2 and 2 even cells here. If this is 2, then this is 3. It's pointing at itself and 1 even cell here. And then 1 even cell there. Okay. Not as restrictive as I was hoping. Could still be 3 and 5. That seems to work fine. Two eliminates 2 here. Hmm. So this counts all the even digits in here. This counts all the even digits, including this one, but that's an odd digit. So these two must be the same. So this has to be 2, 4, or 6. So that's even. Interesting. Obviously, right now, these can just count as 2. So that's fine. What else do we have? So the only way this is 2 is if this is not 2, which means 2 in column 9 has to be there, so that would be 2 and 1. Obviously, if this is 1, then this can't be 2 or 1. So that's a interesting aspect. Oh, the interesting aspect is one of these is guaranteed to be 2 and 1 here. Or 2 and 1 here. And, so if this is 2 and 1, we have an even here and even here, the rest must be odd. If this is 2 and 1, this is even here, and the rest must be odd. Huh. Six and five is not as restrictive though. Um, hmm. Mm. And obviously 4 and 3 here aren't very restrictive. Oh. Can this ever be 6 and 5 is the question. 6 and 5. Oh. If this is 6 and 5, that makes that 3. This has to be 1 and 2. But this 1 would force this to be 2. And this doesn't work. Because we see 1 odd here, 1 odd here. There's only one. This is definitely even, which gives us 4 evens in the box, which would force both of these to be odd. And then this would see 1, 2, 3, 4, 5 evens at most. Like that fails. Therefore, this cannot be 6 and 5. It has to be 2 and 1. 2 and 1 here, which eliminates 1 and 2 here. This becomes a 3-5 pair. Where is the 2 in column 9? It must be one of these 3 digits, which eliminates 2 in the rest of the box, so this can't be 2, so that's 1, which means that's odd. This sees 2 evens, so the remaining digits in this column that it sees are odd. Or, sorry, diagonal it sees are odd, because it sees even here and even here. This can't be 2 or 4, it's 3. No 4, 6, or 8 here. That makes this 3 there, which makes that 2, so this is even. 2 evens means one of these is even, and then one of these is even. These are both odd. 3 is guaranteed here, 3 is guaranteed here, which means the 3 remaining in column 7 has to be one of these 3 here. Because there's no 3 available for column 7 in these boxes here. So this must match this, so it's 4 or 6. So this is the same digit. A and A are the same. 2 is here, which means this can't be 2. Where's the 2 in row 5? It must be here, so that's 2, which is even. No more 2 here because of 2 in the box. So 2 has to be one of these 3 digits there. One of these is even. And this is even. That eliminates even. And that's 4 evens in box 4, so the rest cannot be even. They must be odd. So no 6, 8 here. It's 5, 7, 9. We have a 5, 7, 9 triplet in row 4, which eliminates 5, 7, 9 in the rest of the row. So that means this can't be 5, 7, or 9. It's 3. This can't be 3. 3 eliminates 3 there, so it's 5 and 3. That means this must be 4, and this must be 4. So there are 4 evens along this diagonal instead of 6. There are 3 here. These are all even because of the 5, 7, 9 triplet in the row. One of these must be even. That's the other 6 or 8, so this can't be even here. It must be 5, 7, or 9. One of these 2 is even. We're not sure which. This sees 5 evens on this diagonal. We have only, so 4 more out of these 6 are even. We don't know which, though. We have to have a 2 somewhere in these cells here for column 2. 3 is one of these 3 cells here in column 3. It's probably column 1. This sees at least 2 even cells. 1 odd. So that's 2, 3, 4, 5, 6 at most. So no longer 7. No 1, 2, 3, 4. It could be 5 or 6 here. Interesting. 5 eliminates 5 here, so this becomes a 7, 9 pair in column 9. This remaining digits here are 2, 6, and 8. We have to have 4 remaining in box 9 as the lone even digit, so this can't be 4, so it must be odd. So 4 cannot be here because of 4 in the row, whereas the 4 in column in box 9, it has to be here. So this is even and 4. That means we have 1, 2, 3. Either way, if this is 5, 5 will be odd, and therefore would have to count 5 evens here. If this is 6, 6 would be even, and would have to count 5 more evens here. So these are both even. Okay. So this is even. That's the only even that's counted in column 5 by this 1. So then these two are odd. This has to be odd. This counts. We have 1. One of these is even here. One of these is even here. Oh, 4 has to be one of these two. And 4 cannot be here because of 4 in the row. There is no other place for 4 in column 3, so 4 has to be here, which is even. That means the remaining evens in column 3 have to be seen by this arrow. So this must be odd. That eliminates 4 here, so that's 2. No 4 here. No 2 or 4 here. 2, we have to have a 2 remaining in column 5. It can't be here because of 2 of them boxes, so 2 has to be here. That eliminates 2 here. Where's the 2 in column 2? It must be there, so this is even. That eliminates 2 in both of these rows 7 and 9. That leaves the 2 remaining in row 8 as there. That gives us 8 2s. We know where the last 2 has to be. It has to be there. Okay, so this is 2. This is 1, 2, 3. We have 4. How many 4s do we have? 4 in row 7 has to be one of these 2. And it could be any of those 3 in row 3. Obviously, it's one of these 2 in row 4. So which ones are done? This one's done, that one's done. This one, oh, this already sees 1, 2, 3 evens. That means the rest of the diagonal is odd. Then we see 4 evens here, so this is odd. So these are both done now. 5, this is not done. 2, it sees itself and the other even digits, so this is odd, and this is odd. So no 4 here. This cannot be 6 or 8. That leaves this as an even digit here. So this cannot just see one even digit on this diagonal, so this must be at least 3. So these are done. This sees 3, so that's done. 5 is not done. 1 is done. 2 is done. 4 is done. 3 is done. 1 is done. 1 is done. 4 is done. 2 is done. 3 is done. This cannot be 5, 7, or 9 here. It's 6 or 8. We have 1 even here. Only in column 3. That means this is an even odd pair. That's 5 odds in box 7, so that leaves this as even. So we have 1, 2, 3 evens now. One of these 2 is even. One of these 2 is even. We don't know which. This sees 4, that's fine. That's not done. This sees 1, that's done. So we just have this one left. And this one. That's 2. At least one of these two is even. Oh, we have a 4-4 pair. We have a guaranteed 4 in columns 4 and 6 in row 3, and a guaranteed 4 in rows 7 in columns 4 and 6. That eliminates 4 in the rest of those columns. So no 4 there, which makes that a 4 there. This is 6 or 8. We don't know which. It must match this one, though. Because this cell here means this can't be that 6 or 8. So we'll now mark this as A, this as B. B has to be over here for 6 and 8, which means A as 6 and 8 must be one of those two, which means that B. So B here means this must be A here, which means this can't be A. That's B, which makes that A. So B has to be one of these two there. Okay. A is guaranteed here. This can't be 4. So what is this even cell? It has to be a 6 or 8, and it must be B, which eliminates B from being there. So this cannot be 6 or 8. It's then a red cell, which makes that blue. So that's B. This is 1, 2, 3, 4, at least. So this cannot be 3. It's at least 5 or 7. We don't know which. Okay. This is B, that's B, this must be A. That leaves that as B. We have B here, B here, B must be one of those two. B here, B here, B must be one of those two. Oh, we have 5 odds in column 5. That eliminates odds in the rest of the column, so these are even. No, this is 6, 8 as a pair, so B is one of these two. B is one of these two guaranteed in columns 5 and 7. That means a guaranteed B in 1, 2, a guaranteed B in rows 1 and 2. That eliminates B in the rest of row 1 and 2. So this cannot be B, which means this is B here. So B must be a 6. So B has to be 6. That leaves A as 8, but we don't know which one of these is A. So these are 8. So no more 6 here. No 6 or 8 here. This is odd. This sees 1, 2, 3, 4. This is even. So that's satisfied. Really, this was satisfied either way, but 8 has to be one of these two. We don't know which. This is a 6, 8 pair here. We definitely know at least one of these two is even, but we don't know if both of them are even. One satisfies that, one satisfies that. Oh, is this done? No. So we have 1, 2, 3 evens, and these are both odd, so the rest must be even. So that satisfies that. So this has to be 4. That leaves this not as even. That's odd. This is even. That's 4 evens in box 7. So that last one must be odd. This is 8. We have 4 evens in row 8. So this must be odd. 6 eliminates 6 here. This can't be a 6, 8 pair because of 6, 8 in the rest of the box. Of the 6, 8 pair in the box, so this is 7 or 9. We have a 7, 9 pair in row 2, which eliminates 7, 9 in the rest of the row, so this is even. And that still doesn't help us with that. We have a 5, 7, 9 triplet in column 1. That eliminates 5, 7, 9 in the rest of the column. So this becomes a 1, 3 pair here. That eliminates 1, 3 in the rest of the box 7. So this is 5, 7, 9 here. That eliminates, not one of these is guaranteed to be 9, so that eliminates 9 in the rest of the column here. This is 5 and 7 then. And this must be the same as this one, so we'll mark that one as A. One of these two is A here. Okay. 4 cannot be here. Where's 4 in box 2? It has to be here. That's even. We have 4 evens in the box, so the rest are odd. That means we have 5 odds in column 4, which eliminates odds from the rest of the column. So this is even. That makes this odd there. We have 5 odds in row 3. This can't be odd, therefore that's even. We have 4 evens in column 2. This can't be odd, so this can't be even, so this is odd. And here we see 1, 2, 3, 4, 5, 6 evens. It cannot be just 5, so this must be 7, so that's even there, which makes this odd there. That gives us 5 odds in column 7, so this can't be odd. It's even, which makes this odd. So obviously this can't be 8. This must be 8 now there. So that's 6, which makes this 8, which makes that 6. This is the last 8 in the column 4, and this must be 8 in row 3, and 8 in row 6. And the rest is just normal Sudoku. Okay, 1 eliminates 1 here, so this is 3 and 1. That's 3 in the corner. We celebrate because we're almost done. This sees 7 even cells here. So then that's done, and that should be all the even arrows pointed out. 7 eliminates 7 here, so it's 9. That eliminates 7 and 9 here, so it's 5. So no more 5 in this row and box. 9 eliminates 9 here, so that's 7. Again, the 7 has to match the A here, so that's 7 there. No 7s here. Remaining digits in box 1 is a 5. We have 1, 7, and 9 remaining in box 3. 7 eliminates 7 here, so it's 9 and 7, which eliminates 7. It eliminates 7 here, so it's 9. No more 9s here. No 9 here. Where's 1 in row 8? Cannot be here because of 1 in the box. Can't be here because of 1 in the column. So 1 has to be there. That gives us... Right, where's the 1 remaining in column 6? Can't be here because of 1's in the boxes, so 1 has to be there. That gives us 8 1s, so the last 1 is there. 3. Where's the 3 in row 1? Can't be here because of 3 in the box, so that means that's 3. Where's the 3 in column 5? Cannot be here because of 3, or can't be here because of 3's in the boxes. Can't be here because of 3 in the row, so 3 is there. That eliminates 3 there, so the last 3 is there. That's 8 3s. 5. Where's 5 in column 4? It must be there. That doesn't help us very much. Remaining digit in box 2 is a 9. That eliminates 9 here, so it's 7, which makes this 9. 7 eliminates 7 here, so it's 9. Again, this can't be 9 here. Where is 9 in row 8? Cannot be here because of 9 in the column, so 9 has to be there. We are left with 5, 7, and 9. This can't be 7. because we're guaranteed a 7 in one of these two cells for row 9 here. That means where's the 7 in row 6? Or sorry, it's row 7, it has to be here. 7 eliminates 7 here, so it's 5 and 7, which eliminates 7 here, so that's 5 and 7. 5 eliminates 5 here, so it's 9. This can't be 5 or 9, it's 7. No 7 or 9 here, it's 5. Which eliminates 5 there, so it's 9 and 5, which gives us a 5 there. And that's a solution. Yeah, pretty interesting, actually. The even arrows was not very restrictive at all, but it was interesting how it interacted sort of with itself and the possibilities in each row and diagonal and column. It was very interesting how they interacted. Yeah, nice little puzzle. There are definitely some interesting repercussions of having each even and odd digit being a certain way, right? So that's pretty fascinating, actually, about how it interacted essentially with its own rule set to force certain restrictions. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.